Chapter 15, we are still going to be using our time value of money keys. Now we're going to add the payment or the PMT key. So that's what's called an annuity. So an annuity is basically an annual or periodic payment that comes in the exact same amount over a period of time. So like if you save $1,000 in your IRA every year for 20 years, that $1,000 is what is called an annuity, and that $1,000 is going to go into the PMT key in our time value of money keys. There's two different types of annuities. There's the ordinary annuity, which is when the payment is made at the end of the period, or there's an annuity due, where the payment is made at the beginning of the period. And the textbook will talk about both. We will always only have an ordinary annuity. Your calculator should come set to end. If it's brand new, you don't even have to worry about it. It'll be set to end. If maybe it's used or you borrowed it from somebody, double check that it is. You can hit the second menu button and the PMT button, and it'll show you end if it is. Also, if you would look in the top corner of the display, there would be a BGN if it was set to begin. So we will never switch to begin just because the answers are very comparable. You end up with a little more money if it's an annuity due, if it's the begin, because the money goes in first and the interest goes in again at the start of the year, so it ends up building faster, but it's still somewhat comparable. And then you can easily switch your calculator and then forget about it, and then you'd end up missing a lot of problems. So we'll stick to end. So again, now we're going to go through more problems, but then now maybe instead of having a present value, you're going to have that payment. Maybe instead of having a future value, you'll have that payment. There'll be times if we're saving for something that we compute the future value given the payment to us. When you don't have a present value, then you can get in the habit of making the payment negative just so you never end up calculating the question wrong. The cash flow needs to go the opposite direction as the future value. If you ever have problems where it's going to be withdrawals, for instance, you save for college, and then once your children get to college, they start withdrawing from that fund, or you save for retirement, and once you retire, you start withdrawing. Any of those types of withdrawal ones, we're normally always computing the present value of those withdrawals. So just kind of read those careful and keep that in the back of your mind, that if we're computing withdrawals and we want to know how much money we need to have, we're computing the present value. And this slide is a good example of that. So it's retirement. And you will have this on your test, but even not for the test standpoint, just to understand it for your own standpoint is a great idea. So with this example, if we're saying when we retire, we want to be able to withdraw $20,000 each year after we retire. We estimate, say if we retire at the age of 65, we think we're going to live to be 90. So we estimate our lifespan to be 25 years after we retire. How much do we need to have saved if we earn 8%? So the key to this is, okay, we've got 25 years of retirement. Our IY is 8. The amount that we're withdrawing each and every year becomes our PMT. So remember that if it's each and every year, each and every month, whenever it is, that is going to be your PMT. That is an annuity. So that's where the 20,000 goes. This is where students struggle, is between the future value and the present value. So like I said, you're making withdrawals, so that normally is an indicator to you that you're computing the present value, but also think about retirement. The future value of retirement, the future of retirement is death. So when you die, you don't need any money. So the future value is 0. Then you compute the present value to say, okay, you would need to have $213,495 saved in your retirement account so that the day you retire, you can start withdrawing that $20,000 and have that in your account. I guess you wouldn't. We're doing it at the end, so you would withdraw it at the end of the year. Then the second part's going to say, okay, if that's your goal, if you want to have $213,495 and you have 20 years to save, so now you're back in time. If I'm retiring at 65, okay, say I'm back at 45. So how much should I save each year to achieve my goal? So what I just computed as my present value now becomes a future value because I'm going back in time. I still have 20 years to save, so that's my N. My IY is 8 because we just assume that's what we're earning throughout our retirement savings. I'm not starting with anything today, so I'm going to zero out that present value, and then I'm going to compute the payment. So I would need to save $4,665 every year from now until I'm 65 to be able to withdraw $20,000 a year. Then the final section of this chapter deals with sinking funds, which are primarily more for big businesses or organizations that are saving up a large amount of money. So normally what they'll tell us is that they need to have a certain amount at a certain time in the future. So they're going to add on to their building and they need $300,000 in 5 years. Or it's a city and they're building a new stadium and they need $5 million at the end of 5 years. So whatever they need to have in the future, that becomes our future value. They'll tell us how long they have to save and then what rate they're earning. And then we'll zero out the present value because they're not starting with anything today. And then we'll compute the payment.